Hello, today we are going to be going over the SOL 8.9 and SOL 8.10 warm-ups. SOL 8.9 covers the Pythagorean Theorem, and SOL 8.10 covers the perimeter and area of composite figures. So number 1 says to determine if the following triangles are right triangles. So we know that something is a right triangle if it follows the Pythagorean Theorem, which is a squared plus b squared equals c squared. When we're determining if something is a right triangle, we assume that the longest side is the hypotenuse. So in this first triangle, the 25 inches is going to be C. That means our other two sides, 15 and 20, are our two legs, or A and B. Now, even though this appears to be a right triangle, we can't assume. We still want to use the Pythagorean theorem, because that could be an 89-degree angle or a 91-degree angle, and then it's not a right triangle. So I'm going to substitute in 15 for A. I'm going to substitute 20 for B. And I'm going to substitute 25 for C. Now I use a calculator. 15 squared is 225. 20 squared is 400. And 25 squared is 625. Now we're going to simplify the left. 225 plus 400 is 625. And since this forms a true statement where 625 is equal to 625, this is a right triangle. Now let's look at the other side. Again, if we want it to be a right triangle, it has to follow the Pythagorean theorem. So a squared plus b squared equals c squared. And we're going to assume that the longest side is the hypotenuse. So that's 13. And then our other two sides, 7 and 9, are the legs. So for A, I'm going to substitute 7 squared. Or for B, I'm going to substitute 9 and then square it. And for C, I'm going to substitute 13 and square it. Now we start simplifying. 7 squared is 49. 9 squared is 81. And 13 squared is 169. We want to simplify the left, so 49 plus 81 is 130. And we end up with an untrue statement because 130 is not equal to 169. So this is not a right triangle. And actually, because our c squared is greater than a squared plus b squared, with the converse of the Pythagorean theorem, we actually know that this is an obtuse triangle. Now let's look at the bottom. Question number 1 says calculate the perimeter. Whenever we're dealing with composite figures and we're dealing with perimeter, I always tell students to put a star or a symbol at one of the corners. We're going to go around and we're going to make sure that we add up all of the sides until we get back to our symbol. So here we have 4. But down here we have an unmarked side. So we have to use the information given to us in order to find the missing side. Well, we know from here to here is 8. And we know from here to the end is 5. So altogether, that side is 13. So we can go ahead and add 13 to the 4. Then we have 2. Then we have 5. Here's another unknown side, but we can use what information is there to figure it out. We know that from the bottom to the top is 4, but we've already gone 2 steps to get there. So that we have 2 more steps to go. So this is 2 centimeters. We can add that onto our perimeter. And we end with 8. I also tell students to double check and make sure that the number of sides in the figure is the same as the number of sides that you have in your formula. So 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So we have the right amount. So now we just add them up. 4 plus 13 plus 2 plus 5 plus 2 plus 8 is 34. And perimeter is always in single units, so it's going to be in centimeters. Number 3 asks us for the area. Now, if we're looking at our formula sheet, there is no shape that looks like the one in the problem. So we need to subdivide this composite figure into shapes that are on this formula sheet. So I'm going to divide here. Now I have a rectangle and I have a trapezoid. So first let's find the area of a trapezoid. If we look at our formula sheet, the formula is right here. It is 1/2 times the height times the sum of B1 plus B2. So 1/2 times the height times the quantity B1 plus B2. If we look at our trapezoid, our height is right here. And right now it's an unknown quantity. We know that to get all the way across is 20, but we've already gone part of that route by taking 14 steps. So that means we have 6 more steps to go. So that missing side is 6. We have one of our bases, B1 is 4, and base 2, since it's a rectangle, is the same as the other side of the rectangle, so it is 8. So when we put this into Desmos, H is equal to 6, B1 is equal to 4, and B2 is equal to 8. Now when you put this into Desmos, I recommend using different variables than B1 and B2. You can use any letter that you want as long as you're consistent. Just don't use H. I'm going to use A and B to make it easy. So 1/2 times H times the sum of A plus B. And A represents B1 and B represents B2. H is equal to 6. A is equal to 4. And B is equal to 8. So our area for just the trapezoid is 36. So I'm going to kind of put a 36 in here so we know that we're going to use that later. Now we need to find the area of the rectangle. If we look at our formula sheet, the area of a rectangle can be found with the formula LW. So the area of the rectangle is equal to LW. We have our length of 14 and our width of 8. So if we put that in Desmos, our formula is LW, and L is equal to 14, and W is equal to 8. So our area is equal to 112. Now we need to add our two areas together. So 36 plus 112 is equal to 148. And since this is area, it is in square meters, or you could say meters squared. I hope this video was helpful for you. If you have any questions, you can always email me or leave them in the comments below.